So chlorine and hypochlorite. What do they do? Like, why do they work? How do they work? They disrupt the bacterial membrane, for one thing. All these oxidizing agents, they're really good at just breaking down chemicals, molecules. Probably proteins are going to be one of the big things that we break down with chlorine. And then when you break down that protein, you've got proteins that transverse the membrane and that help keep it together. So you break that protein and you break that bacterial break that membrane. It can also disrupt the enzyme function. Enzymes are also proteins. So again, we're just breaking the protein. We change the structure of the protein. Now the enzyme can't do what it's supposed to do, and the bug dies. It can denature the nucleic acid, that's DNA and RNA. That messes up how the biology that's occurring. It can alter the permeability of the cells. And because it's doing all these things, because it's just reacting with the biochemistry in a molecule, if you've got some sort of protective layer, then the chlorine is not going to work as well. Like cryptosporidium. Crypto, I said, was a larger organism. It's a eukaryotic organism. It's not a single cell organism. And so with that, it also has like a skin or a shell around it. The chlorine will sort of just interact with that shell and that skin, and it'll use up the chlorine without really damaging the internal components of the cell. So you end up having to increase your concentrations to be able to kill crypto. Now, along with chlorine, we have other chemicals that we use that are chloramines. This comes just when you react chlorine with ammonia. So if you have ammonia in your source water, which is pretty common, you can form chloramines. So it's an advantage, or it could be advantageous and it could be disadvantageous depending on the situation and the concentrations we're talking about. Chloramines, they actually have longer lifetimes in water. So Katie, you mentioned the residual. You needed it to last to your longest customer. Chlorine residuals can go up to, a day or so, 20 hours, 24 hours, something like that. Maybe longer if you increase the concentration. But chloramines will last even longer, a couple days. So if you have a huge distribution network, then you might want to use chloramines. Pretty amazing stuff, huh, Alex?
I'm good.
Yeah. Yeah, he's like, man, a longer lifetime. Oh my goodness, that's amazing. Glad you like it. All right, so and chloramines have fewer disinfection byproducts than chlorine, so a lot of people have been switching to chloramines for that reason. Unfortunately, even though it has fewer disinfection byproducts, there are some DBPs that come only from chloramines. One of the main ones that we care about is NDMA, N-nitrosodimethylamine, and we'll talk about that a little more later. The disadvantage with chloramines is that they're slower acting, they're not as powerful as chlorine, and so it's a less effective oxidant, or sort of because of those two things are related. And because of that, we usually use it in combination with other disinfectants. So we use chlorine first to do our major disinfection, then we'll add chloramines at the end to give us our residual, is one thing that we can do. And again, it's going to disrupt the enzyme functions here. So we've got another example. Again, it's more chemistry that we have to do. We have to figure out what's the mass speed rate of chlorine and ammonia to achieve monochloramine residual of 2 milligram per liter if we have a flow rate of 1,700 meters cubed per day. Let's again there, Jason. You can go ahead and start, cut it and start a new one there.